Hello students, welcome to the next video on the chapter Atomic Structure for class 7. If you remember, we have read about the structure of an atom and how proton, neutrons and electrons are found inside and around the atom. Today we will be discussing about ions. Now if you remember last class when we had discussed about molecules, if you remember about molecules, you know that molecule is the smallest particle of a pure substance which is capable of independent existence. Now we had also read about the molecular formula, how the formula is made, and also about atomicity. Now when we talk about ions, you can see it's written that a charged atom is known as an ion. So what do we mean by a charged atom? Charged means it is either having a positive charge or a negative charge. So when that ion is having a positive charge, we call it cation, and when it has a negative charge, we call it an anion. Some examples like potassium, calcium, you can see +1, +2, +3. These numbers which are written on the top, they are actually called the valency. Now why does this happen so? Let me just give you a quick small brief on it. That what happens is when you see a plus sign, that means it is giving away the electrons. If you recall, last time we told you that atom is consisting of the electrons which are revolving around the nucleus. So when it gives those electrons to the other atoms, it becomes positive. And when it takes electrons from the other atoms, it becomes negative, because the number of electrons increases, and you know that electron carries a negative charge. So you just need to remember this basic. How it is happening you will be learning in higher classes. So when we say that a charged atom is an ion, remember that ion is cation, which is positively charged, and anions which are negatively charged. And here if you see the example, you can see I have generally one term. But when a group of atoms are there that carry overall charge like ammonia, carbonate, sulfate, nitrate, you can see more than one atom is there which is grouped together, and overall it is having one charge. Like when we talk about in ammonia, there are two elements, nitrogen and hydrogen. But when we talk about ammonia, it is a polyatomic atom which is acting like a single unit, and the charge of it is +1. Similarly, you can see here carbonate, which is a negatively charged ion, means that is a polyatomic anion, you can say. And this is a polyatomic cation because it carries a positive charge. So does sulfate, made up of sulfur and oxygen, and -2. -2 means it is a negatively charged polyatomic anion. So polyatomic means it is having more than one element in it. Okay, a group of atoms here, they are called the polyatomic ions. Now moving on to valency. You might be thinking, what is valency? It is the combining capacity of an atom or an ion. How it combines with the other atom or ion will determine the valency it has. So generally if I talk about valency of element, it is the number of hydrogen atoms that can combine or replace one atom of the element. For example, if I say water, you know the formula of water is H2O. Here you can say that one atom of oxygen combines with two atoms of hydrogen, and so the valency of oxygen here is 2. Similarly, if I say HCl or hydrogen chloride, you can say that one atom of chlorine combines with one atom of hydrogen, and here the valency of chlorine is equal to 1, because we are taking hydrogen as 1 in all the cases. And similarly, there are some elements which have the variable valency, that is more than one valency they are having. It can be like non-metals like nitrogen, sulfur, phosphorus, and also the metals like iron, copper, they are having variable valency. And what are the valency of the ions? The valency of an ion is the same as the charge it has. So if I say chlorine, Cl-1, chloride, so the chloride ion is having -1, so that is its valency. Now if we try to make a relationship between the periodic table and the valency, firstly you might be thinking, what is a periodic table? Now periodic table is a specific table or a compact arrangement of 118 elements which has been discovered and synthesized both, which are arranged in 18 columns and 7 rows. It was given by Mendeleev, the Russian chemist, and there were many other scientists who had worked on it, but Mendeleev had given a very appropriate one. And in this you can see the horizontal rows. These are the horizontal rows which we call it the period, and the vertical columns are called the groups. Okay, and this is a rough arrangement of the periodic table till the element 20, which you need to remember for class 7, starting from hydrogen, helium, lithium. Now the relationship that we see between the valency and the periodic table, if you can just see the table, you will understand that the first 20 elements, they are listed along the valencies here in this. If you observe carefully, in the bracket I have written the valencies it contains. So you see from left to right, when I move towards the center, the number is increasing till 4, and then again it is decreasing, and the last column is containing 0 valency because they are noble gases and they don't have electrons to give or take. So if you say hydrogen, lithium, sodium, potassium, they all are having valency 1 and they are grouped in the single group. And similarly barium, magnesium, calcium, they are having valency 2. Boron and aluminum, they are having valency 3. So they are in the group 3A. So if you see the naming of these groups, you can see that this is called the 1A, this is called 2A, 7A, and then this is a 0 group. This last group is called the 0 group. So as you can see in the fourth one, we have carbon and silicon, and nitrogen and phosphorus are in the 5th group, 5A group. So similarly you can say that the 8A, this is the 8A group, which we call the 0 group. So, and it is containing only the unreactive inert gases. You know, helium, neon and argon, they are the unreactive inert gases. So the elements in the same column, as you can see, of the periodic table, they are having the same valency. These are the columns, so they have the same valency, and that is why the physical and chemical properties are also very similar. So that's the relationship between the valency and the periodic table. So what can we say? I'm just repeating myself that the elements, as you can see in the same column, have the same valency. This bracket ones in the orange, what I've written, they are the valency, and they are same in a column. Also that indicates that the physical and chemical properties are found to be quite similar, and so I can say that is a relationship between the valency and the periodic table. Now moving on to the molecular formula of the compounds. Now when we are going to write the formula of a compound, it is the representation of the element or compound using the symbols in the element present and the number of atoms of each element in a molecule. So suppose I write zinc hydroxide. Now once you have learnt valency, you will know that the valency of zinc is Zn plus 2 and that of hydroxide is OH minus 1, or OH only minus can also be seen. Nothing is there means it's 1. So what happens is we have to write the symbol. You can ignore the positive and negative, you just write the symbol along with the number, and then you have to cross multiply. Means the 2 will come below OH and the 1 will go below Zn, and we will not write the 1. So it becomes something like Zn OH in bracket whole twice. Now why am I putting a bracket? Because OH is more than one element, so it is a polyatomic ion, so we need to put in bracket. Similarly, if I say magnesium nitride, you know that magnesium valency is plus 2, nitride is N minus 3. So you can just write Mg2 and N3 and do the cross. So what will happen when we do the cross multiplication? The 3 of nitrogen will come down and the 2 of magnesium will come here. So it becomes Mg3N2. I'll show one more example. Suppose I write barium chloride. Barium valency Ba plus 2, chloride is Ca minus 1. So if you see something is common now in all this, that I am always using a positive and a negative ion to combine together, not a positive and positive or not a negative and negative. So it becomes BaCl2. I am not writing the 1 because that is not needed. So the molecular formula for barium chloride becomes BaCl2. So what are we doing, students? We are writing the symbol of the elements along with the valencies on the top as a superscript and interchanging the valencies and bringing them down diagonally. So the 1 comes here and the 2 goes there. So 1 we do not write, and if any other number is there, we have to represent it like this. So now you can try to make different formulas combining the cations and the anions. Moving to the last part, that is significance of the chemical formulae that we are writing. So you can know about the component elements of one molecule of a compound, and you can know the number of atoms of each type and the ratio in which they are present, and also the mass of the molecule can be known by adding the atomic masses. For example, if I want to write the formula of potassium nitrate, you know potassium is K plus 1, nitrate is NO3 minus 1. So when there will be exchange, nothing will come down because both are 1. So the formula becomes KNO3. So what do we understand from this formula that you see? You can understand that this molecule consists of potassium and nitrate ions, right? Now if I tell you that one molecule of potassium nitrate is consisting of one atom of potassium, one atom of nitrogen and 3 atoms of oxygen, and I can write the ratio as 1:1:3. So you can write the ratio also like this. The mass of potassium is 39. This you get in the periodic table. The mass of nitrogen is 14. The mass of oxygen is, because it is 3, we have to multiply 3 into 16. So when we solve, so after solving we get the value 101. So that is the mass of one molecule of potassium nitrate. Thank you for watching.